Welcome to this series. In the next several videos, we will discuss software and operating systems and introduce human-computer interaction. System software is a large topic, so we'll break system software into two parts. This first presentation focuses on programming languages and compilers. Please take a moment to read the learning objectives for this video. Programs, software, and programmers are terms you probably heard. But let's define them so you can better understand computer software. A program is a set of sequential instructions that tell the computer what to do. Another term for a program is an application. Software is a collection of programs, data, and information. Software is in contrast to hardware. Software tells the hardware what to do. A programmer is someone who makes a program or develops software. There are two major branches of computer software, which are system software and application software. System software is for system processes. Application software is for the user. System software is software that the computer uses and that operates a computer system. System software is usually included in the computer, such as embedded software. Examples of embedded software are firmware for the hardware and the BIOS. Embedded software usually interacts with the hardware. It acts as an interface to the hardware. Other system software is installed later, but still necessary for the system to function. An operating system is system software that manages applications and allows them to interact with the hardware. The first subgroup of system software is programming languages. To understand where software comes from, we need to describe how a programmer writes programs. Software controls hardware and tells it what to do. Programmers need a way to create the software. Programming languages allow the programmer to create programs that control hardware. Engineers develop programming languages to help programmers write software. Programming languages consist of a set of rules that programmers use to process data. There are many programming languages, each designed to solve specific kind of problems. C is a low-level language that gets the programmer close to working directly with the hardware. C# is a high-level language which is closer to human language for rapid development on Windows computers. Java is a cross-platform language. PHP, ASP, and Python are web languages. There are different levels of programming languages. Each language gets the programmer closer to the hardware. Ultimately, every program will interact with the hardware. However, it's easier to work in a high-level language. We will discuss each in greater detail. Hardware operates in machine languages, which could be a number system based on binary, octal, or hexadecimal. Computer architecture will use different numerical notations. Writing code in a number system is very difficult and time-consuming. Instead, programmers write programs that translate human-readable code into machine language. Here's an example of machine language. You can see the code in the basic language that accomplishes the same result. You can read one without having to know the codes. Assembly language is easier than machine language, but is used only when programmers need to interact with the hardware. One might use assembly code to control a microprocessor directly. Programmers use code words such as add, sub, and etc. to execute commands. Assembly language needs an assembler to translate the instructions into machine code. Here is an example of assembly code. It's easier than machine language, but still difficult to use. High-level languages use statements and words that programmers can understand. Programmers use high-level languages to easily solve complex problems since they can focus only on what they want to do, not on specific codes required to directly control the hardware. Examples of high-level languages are C#, Python, Java, PHP, and JavaScript. These languages still need to be translated into machine code. This comparison shows the differences between the high-level code and the low-level machine code. Other softwares, such as compilers, generate the machine code from the human-readable code. Application languages are programming languages built into applications. Power users can use their built-in languages to manipulate the data. One example is Visual Basic Script in Microsoft Office. Databases often use their own language that allows programmers to create files, forms, and query for data. The next category of system software that we discuss is compilers and interpreters. As you have seen, programmers do not write programs in machine code. Instead, programmers and engineers develop software that translates human-readable code into computer code. The computer code is the exact instructions that tell the processor what to do. Compilers and interpreters are the programs that translate the source code into computer code. The job of compilers and interpreters is to turn the source code into machine language, which is a low-level language. Compilers and interpreters differ in how they execute the source code. An interpreter directly executes the instructions one line at a time in the source programming language, turning into machine code. It interprets, compiles, and then executes the line in the high-level language, and then moves on to the next line. A compiler translates all of the instructions into efficient machine code. Here is an example of compiler translating the source code into the binary format that the computer can understand. Interpreters translate and execute one instruction at a time, which is slower than the hardware directly reading machine code. However, interpreted languages are common in scripting and web-based languages. JavaScript and PHP are interpreted languages. In summary, programmers create computer software for two major subcategories, which are system software and application software. System software operates the hardware and allows the system to run. It is software for the system, not for the user. Programming languages allow programmers to write software. These programming languages are classified either as a high-level or low-level language. High-level languages are closer to how humans talk. Low-level languages are closer to how computers talk. Compilers and interpreters are programs that convert human instructions to machine language.